So be careful. CD is cutting AB in half. CD is not getting cut in half. CD is cutting AB in half. So the first thing I would do is put tick marks on either side of E. E is a midpoint. And this was on your homework. Okay, so AE is 3x squared minus 8. And EB is 92 minus x squared. Find x and the length of AE. So we've learned by now that when we have a midpoint and I give you half and half, that we simply set them equal. We don't add them, we don't subtract them, we set them equal. You put one half on one side of the equal sign and the other half on the other half part of the equal sign. So we've got 3x squared minus 8 equals, because it's a midpoint, equals 92 minus x squared. Now remember, I gave you a hint. Whenever you have an x squared, that means you're automatically going to have two answers. If you don't have two answers, then you did something wrong. So make sure if you have a quadratic, if you have an x squared, that you have two answers for x. All right, ready? What do we want to do first? Let's add x squared to both sides. That's gone. 4x squared minus 8 equals 92. I got my calculator out, but I'm not going to need that. Plus 8 plus 8. 4x squared equals 100. Divide by 4. X squared equals 25. This is not a factoring problem, although you could factor it, but we're not going to. We don't treat this one like a factoring problem because it doesn't have a middle term. Do you see how there's no x there? There's an x squared, there's a number, but there's no x term. So that's why we get to, careful, that's not the full answer. That's why we get to square root both sides. And the square root, when you get your answer, there is not one answer. There are two answers. It's plus or minus the square root of 25, which is plus or minus 5. Now, in your quiz, like when you enter it in the quiz, you'll need to put -5, 5. Because I'm not going to make you find the plus or minus symbol and how to find that. Anyways. So we also need to plug it in. We need to actually find the length of AE. So just plug it into one of those and then double it because E is the midpoint. So 92 minus 5 squared, 67. And then double it. 67 times 2, 134. Now, do I need to plug in -5 as well? Well, you could, but when you square the -5, you're also going to get 25, so there's no need to plug that one in as well. You're going to get the same answer. Okay, cool. The answer's to page 2 of the segment addition and midpoint worksheet. You know we love quizzes in geometry. Your quiz over this stuff, there was, remember, 2 sides to this paper? Your quiz over the front and the back of this paper, segment addition and midpoint, that quiz is tomorrow. But the difference is it is a partner quiz. So I will be pairing you up and you will get to share answers with people. You will get to talk about how to solve it. Okay, number 15 from the homework. 3 points F, G, and H lie along a straight line. So they are collinear. Point G lies between F and H. So we don't know where G is, but we know it's somewhere in between. FG is 13, and FG is 1/3 of FH. So what I recommend you do here, it's 1/3 of FH. So I recommend you put a 1 and a 3 for 1/3, 1, 3. 1/3, FG is the 1, and FH is the 3. Now, FG, I spelled fig, FG isn't really 1, and FH isn't really 3. So when that represents like a ratio instead of the actual length, then you attach an X to it. That's one part, and we've got 3 parts total. Now, if you want to keep going and kind of see how this works, if I have 3 parts, and I've used one of the parts, and that means I've got 2 parts left. We didn't really need to do that, but I wanted you to see the whole picture. All right, how long is one of the parts? Well, FG is 13. So one of the parts, X, is 13. I want to know what FH is. Well, it's 3 parts. It's 3 times X. So all you do is 3 times 13, and you get that the whole segment is 39. So FG is 13, GH is 26, and the whole thing is 39. 13 is 1/3 of 39. 17 is really just like 15, except we gave you much uglier numbers, okay? So on this one, we're in the same boat. We've got A somewhere between, we've got B, and then we've got C. BC is 54/5. This was confusing a lot of my students because they thought it was like a ratio, like it's 54/5 of something. 54/5 is not a ratio, it's just a distance, it's a length. So instead I told my students who were struggling with this to write 10.8 because that's what it is. So BC is 10.8. Then it says AB is 5/6 of AC. AB is 5/6 of AC. 5/6. Give one of them 5 and give the other one 6. So my drawing is not to scale. Sorry about that. 5 is not the length and 6 is not the length. So you need to put an X and you need to put an X. Those represent like ratios, portions. All right, so if I have 6 pieces and I've used up 5 of my pieces, that means I have 1 piece left. So that means X, 1 piece, is worth 10.8 units. I want to know how long the whole thing is. That is 6 pieces. The whole thing is 6 pieces. So I take 6 and I multiply it by how much 1 piece is. 6 times X, 6 times 10.8. And that's how you get your answer on that one. So the answer was either 64.8, or on your calculator you can do math, enter, enter, and the fraction is 3/24. Okay, constructions are used to find out how geometry works, and they're also used to prove geometric ideas and principles. In a construction, for it to be a true construction, you're using a straight edge and a compass. So here's a straight edge. It could be a ruler, but with no markings on it. You can't have markings. And then here's a compass. Yours might look a little bit different, but a compass is composed of a point and then a pencil or a pin. And so a compass makes arcs and it makes circles. So a straight edge is an edge with no markings. So you can use the side of a textbook. You can use the side of a piece of paper. You can use the side of your calculator. Those are all straight edges, just something to help you draw a straight line. And a compass, I just talked about that. It draws circles and arcs, which are part of circles. Okay, so what we're going to do is we're going to learn how to copy a segment without using a ruler, as in like a ruler with markings on it. We're going to learn how to use a compass to copy a segment. It's going to seem really like, okay, that's kind of silly, but this is just the building blocks to how you construct things, okay? So, if I want to copy segment AB onto this ray down here, what I would do is I would take my compass, I would put the needle on one side, and I would put my pencil on the other end point. So the needle is on one end point and my pencil is on my other end point. That is how long my segment is. To preserve that length, I don't want my compass to move at all. So I take my compass, I put the needle on the end point of the ray, and I simply make an arc. Now if I move my compass away, where the arc intersects the ray, I could call that B prime. It's like A prime is like another version of A, and B prime is like another version of B. It's like B number 2. And so B the second, right? And so now I just copied AB right here. So segment AB and segment A prime B prime are congruent segments. Now sometimes we might ask you to double AB. So how would you do that? Well, you would copy AB onto the ray, and then you would keep your compass at the same setting. You can't let your compass slide. You keep it on the same setting. You put the needle where you left off. You make another arc, and then your new one, let's call it C prime just for fun. Your new one, A prime C prime, is double AB. And we just constructed a midpoint. B is the midpoint of our segment, right? So that's how you copy a segment. Really straightforward, really simple. Now let's go over how you would construct a perpendicular bisector. This is like one of the fundamental things that we do in geometry. This is a really good thing to know, how to make a perpendicular bisector. And the cool thing about it is that when we make this, it's going to stem from radii of circles. So you're going to see how a radius of a circle is going to play into us finding the perpendicular bisector of AB. So, step one is you put your needle on the end point, and then you need to open your compass to at least half as long as the segment. So this would not work. This, ooh, that's too close. It looks like the midpoint. I don't know if it's more than half. I don't care how far you open it, but it needs to be more than half. On that one, I feel safe. I feel like that is more than half. I feel good about that. The next thing you do when you've opened it more than halfway is you make a nice long semicircle, kind of, an arc, a major arc. Do you see how the compass kind of represents the radius of a circle? The next thing that I'm going to do is really key. I'm going to keep my compass open to that exact same opening. Don't let it move. And I'm going to move my needle from A, and I'm going to put my needle on B. And I'm going to flip my compass around. So I flipped my compass around. I'm putting my needle on B, and now I'm making the same exact semicircle, the same exact major arc. What's cool about this is that when I connect the dots, you get my segment tool out, because you're going to use a straight edge, anything straight that you have. When I connect these, like that, and pretend it's perfect because it's hard to, there we go. When I connect those, that segment or that line, if it went on forever, is the perpendicular bisector of segment AB. So I've not only cut AB in half, but I've constructed a line that is perpendicular. And what's cool about that is because these were radii, every point on this line is equal distance from A as it is from B. They're equal distances. So that's kind of what a perpendicular bisector is, and I use the radius of a circle to do that. Okay, I know that was a lot. On my website, I'm also going to have these two links. These are another website that shows the two things I just did, and you can loop it, and you can just watch it do it over and over and over again if you need more practice. So that's what those are. How do you keep it from